How are we doing today? What's up? No. But here's what we will do. Is we're just going to do some of the homework maybe together, and we'll do that, right? We're gonna do some of the homework together. No, new homework. Yeah, new homework together. Well, the homework due Sunday is the rest of the chapter 4 stuff.
Wait, what is double high test?
So you remember in the syllabus at the end of the semester, you get either to double your high test score, you can retake a chapter test capped at 85%. Correct.
Can I do it right now?
So I sent everyone a Google form to indicate what one you wanted to take, which option you wanted to take. Can we all listen?
When did you send it?
Yesterday? The day before?
I see it.
So again, as a reminder, we're nearing the end of the semester, so we drop a low homework score, we drop a low quiz grade, and then I give you the option to double a high test score or to retake a chapter test capped at 85%. I put in the drops the other day, so those have gone in. They'll automatically update, so if new scores come in, the computer will automatically drop whatever's the lowest one in the category. So that's already happened. On your end, will you be able to see what's being dropped? No, but I promise you the computer's doing it and doing it correctly. To decide whether you want to take the doubled high test score or do the retake, I sent everyone a Google form to fill out yesterday. So you should, if you check your email, you should see a Google form from me. Since you guys have all have test grades for all 4 tests, it feels like you're probably ready to fill that out. So if you know what you want to do, go ahead and do that. If you're still thinking about it, we need to get that kind of figured out by sometime next week, so we have enough time to do your test retake if that's the option you want to take. So far, so good?
Like it's about an end express.
Yeah.
Oh, the yes, the
Yeah. So I was like part-time now, stop finding another car, stop behind me, who's poking out from the other lane coming this way. So he gets off, he scrapes the side of my bumper and he speeds away. Oh my gosh, I was so
I would chase someone.
Dude, that
I'm not even
Yeah,
so.
like,
Even
like,
if
Do you know how I think someone in front, they have all those Michigan laws on M24?
oh,
So it was really snowy on Christmas Eve, so I was going like 2 miles an hour turning, so that I didn't like slide off the road. And this truck behind me got mad, turned around me, cut off the whole front side of my car, and just kept driving. And I couldn't chase him because it was snowy.
no.
I would chase
And now,
I don't care.
it's not,
I
it's
would slide.
it's a scratch.
I would literally just stop.
It's really a scratch, but I still have to do like repair it. Because like I understand something was my fault, but that was just.
All right, folks.
Okay.
So what we're going to do is we're going to work on this set of problems 7 through 14. This will be the next part of the chapter 5 homework. What's up here at the top is a group assignment or a grouping. So I assigned you a randomly selected partner, more or less. For the absent people, I had to like fill in some blanks or whatever. Why don't you take a moment and move so you're sitting near your partner, next to, so you can talk about the problems as we're going through and doing them. So next to each other is probably preferable. Would probably make communication easiest. Now, my suggestion to you guys, since this is going to be a future homework assignment, is I would write down what we're doing as we're doing this so that you can have part or maybe all of this done when it comes time to do the assignment. Because anything we don't finish here today, you'll finish on your own, but you might be able to finish it all today. Who knows? Depends on how many good ideas you guys have.
I wasn't here last time.
Last class was the test.
Or no, like Monday.
Everybody needs one.
Oh, sorry.
So these are performers.
These are the list of identities that we kind of discovered together on the last lecture. Also, you'll notice on the back of this sheet is the unit circle plus the inverse stuff that was on the test. So if you look at the back of this, look at the back of the sheet I just gave you, it's the unit circle plus that inverse stuff from the test all in one place. So a little updated version. Everybody got one of these? All right. So let's talk about what the purpose and what the goal is of these problems that we're looking at doing right now. The directions say simplify the expression. By simplify the expression, what we mean is we want to get this into a single trig function. So if I look at number 7, this is currently written as the product of 2 trig functions, right? So we have 2 kind of tools in our toolbox to try to simplify this. We can use algebra things, or we can use the identities. So group 1, Colin and Jake, what do we think? Do we think we should try to use an algebra thing or an identity thing to make our next, to do the next thing here? Algebra. Okay, what algebraic thing could we do with this? The algebra is stuff that we know. So like we could factor, we could FOIL, we can distribute, we can make a common denominator. Doesn't seem like any of those are realistic, right? Yeah. Seems like an identity thing maybe is the better route. Yeah. So let's look at our identity sheet and see if there's one that makes sense that involves either cotangent or sine or something. P2. Yeah, so okay. Now, notice P2 is 1 plus cotangent squared. Do we have cotangent squared? We don't. So we probably don't want that one. What identity would be useful here? As I'm asking this question to this group, everyone should be looking at the identity sheet, looking at the possibilities and trying to answer this question for themselves. This is difficult, what I'm asking you guys to do here. The way to get better at it is to practice. Even if it's not your turn, you should be practicing trying to answer these questions and looking. What we're trying to do is build some intuition. Okay? And this is how that has to happen.
So does the one that we choose have to have both cotangent and sine?
Typically that's what you're going to want, is something that has both of them in it. I'd be looking at the top category in the basic identities, because those are all the ones that have just something to the first.
R1.
So R1 has sine in it, but it has cosecant and not cotangent in it. So I probably, well, Q2 has both cotangent and sine in it. Let's use Q2. I think that's a great plan. So while I'm doing notes with you guys, I'm going to write the identity above the equal sign that I'm applying. So if you go back and you look at this, you understand what it is that I did. And what I'm going to do with Q2 is I'm going to replace cotangent with cosine u over sine u. Is everybody okay with what I did there? All right. Avery and Layla. Let's look at what we have now in the red. Identity, algebra. Which one do you think makes more sense to apply now? Algebra, I agree. Specifically, what would we try? So when you say cross multiply, you really just mean multiplying, right? Now, when we multiply two fractions, how do we do that? Straight across. But what would I want to do before I multiply here? I don't want to make a common denominator. That's for addition and subtraction. I don't need to do common denominators for multiplication. Yeah, I can cancel the signs, right? I have a sign on bottom and I have a sign on top. And if there's a multiplication symbol in between, those can cancel out. When they cancel out, what do they become? They become 1, right? So now, if we multiply straight across, what do we have? Over 1 or just cosine, right? Are we going to be able to get simpler than a single trig function? No. Are we done then? Yes. Congratulations. We've just finished number 7. All right. Number 8. Nora and Mariana. Algebra, identity, which one do you want to do? Okay, what algebra would you want to do here? Simplify. By simplify, what do you mean? Because that's just the direction for the problem, right? Simplify the expression. But I want it, like, you're not wrong, but like, can we be a little bit more specific on like what exactly we're simplifying? Yeah, the term you're looking for is reduce then, right? Absolutely. That's a great idea. So what Mariana said is that we have a cosecant in the numerator, we have a cosecant squared in the denominator. It's all just multiplication. Should be able to reduce that just like we would 2x over 4 or something. No, but you can reduce like that, right? Like x over x squared just reduces to 1 over x, right? Kind of in the same fashion. That's an excellent first decision. So far, so good. Okay. Nico and Pauly. We're now at the red, tan of pi over 2 minus x divided by cosecant of x. Algebra or identity? What do you guys think? Okay. What identity would you want to use here? Again, when I ask these guys this question, everybody should be looking at their identity sheet and trying to come up with an answer as well.
Use R3
Well, here's the thing. Eventually, we want to be able to do some more reducing, right, and cross some stuff off. In order to do that, the variable parts inside the trig expressions have to be the same, and right now they're different. So you could do something like R3, but I don't know that it's going to be helpful until we fix this problem that the inside of our trig functions is different. So that's the first thing I'd be looking to try to fix. Hold on a second. I'm going to let these guys Think on it for a second. Oh, you have a legit, okay.
So do you start with one of these and then as you figure it out?
You can, any of them are eligible at any time.
Oh,
Yeah. Any of the identities are eligible at any time. You don't have to start at the top. Yes, let's use C6. What C6 is going to allow us to do is it allows us to replace this with just a cotangent of x. Now the variable parts inside of our trig expression are the same. That's a big improvement for us because now we'll be able to cancel trig expressions if we can get something to reduce, right? Does that feel okay so far?
Yeah.
Great. Ava Sidney. Algebra or identity, and then kind of what are we thinking?
probably.
Okay. Which identity would you be interested in doing?
Even odd identity? Section.
You could use that. I don't know what you're going to do out of there,
What about
since you don't have any negative x's. It's okay. This is again, what we're trying to do today
It's learn.
is I'm trying to build some intuition for you guys on like how to do these problems.
Can we just cancel the x's?
You cannot,
No.
because it would be like these are two different operations, right? It's not cotangent times x, it's cotangent of x.
Oh, but we do P2.
P2, we don't have anything squared,
Okay.
so probably not any of the p's because those have to have.
So would it be a reciprocal?
Okay, which one are you thinking?
Probably.
I know how to do this quite well. What we're trying to do is like let you guys struggle bust through this a little bit so we can get a feel for how this should feel and how to approach this and how to work through one of these problems. And it's okay if it's hard and you're not getting, like you're not being productive, because even in not being productive, getting feedback, you're learning like, okay, I don't want to think about it that way because when I do, Mr. Kulik just says it's not helpful. So how should I be thinking about it? We're going to work through this in real time, all of us together, and build some intuition on how to do this process, right? Because it's not just like, this is the procedure, you just do the procedure every time, every problem's the same. It's not like that.
So.
You should be looking at your identity sheet, because I agree, there's nothing algebraic to do here.
So
Unless you're being very sneaky.
if we do like. Which section?
Is it?
Which category?
Well, which ones have things to the first power? That just x is like just a single variable all the way through.
Pythagorean?
Those are all to the second. Those all have.
Right now? Hang on. Which one is it? Really? Is it reciprocal?
Which one?
Because you
Probably.
can't do co-function because we already did that before. And the Pythagoreans are squared, and then these ones you said you can, but like why would you have those?
Well, you don't have any negative x's,
What
right?
if we do Q2?
I like that plan.
Okay.
Which version of Q2 are you doing? See how one of them is cosine over sine, and the other is cosecant over secant. Which version would you want to use? You have a choice.
Which one's easier?
I'm asking you, which one do you think you should use?
Think about it.
Okay.
What if we do the second one?
I think that's the better choice. Why do you think that's the better choice?
Because Reese told me so.
Because Reese told you so. Reese, why is that the better choice?
Because it has CSC, or SEC, CSC, which is canceled.
Yeah, because we already have CSCs in the bottom. That's exactly what you'd want to do. Okay. Who's the next group? Now I forgot. Reese and Delaney. What should we do next? Okay, so if you think about this also, let me write it with a different color here. If you think about this also as a fraction, you can reduce those like that. Sure. When we cross them off, what do they become? 1. So what does this simplify to then? No. Yes, Nora's got it. 1 over SEC over 1, but we won't write the over 1 part, right? Is that okay? Because we still have this 1 over on top. Now we did. No, R2 is correct. That is what you'd want to do, Delaney. Because what does R2 allow us to rewrite this as? Because a not fraction is going to be simpler than a fraction, right? Ava.
Why did we have a 1 over the CSC? After we did cotangent over x over CSC. Why was there, like after we did Q2, they reduced the ones.
I wrote the over 1 in green, so you could see that we were making sure to reduce numerator with numerator or denominator with denominator, so we didn't accidentally do like a denominator with a numerator, which is something you can't do. Right? So I wanted to make sure I was reducing numerators with numerators.
Okay.
That's why I wrote it over 1 with green, just to remind myself, okay, I can reduce a numerator with a numerator or a denominator with a denominator, but I can't do a denominator with a numerator with a denominator.
Okay.
So that's why I did that, just to be clear that my algebra was going to be correct. Does that feel okay? So that was just a check for myself. So this cosecant is just that one. And the other one was from Q2. Q2 allowed me to replace cotangent with cosecant over secant. In general here, guys, what I think when I'm about to use a Q property, what I often like to do is instead of thinking about that as the fraction, I think about it as numerator times denominator. So when I do Q2, it looks like this, which is a little bit more familiar for me. It's not wrong what we did, but when I think about it, I like to think about it that way. But what you guys have done so far is great. We're doing great. You're doing really good. You're thinking about these things. You're making good guesses, good choices. We're hopefully developing some intuition and figuring out, like, how do I look for an identity that's going to be helpful? So we're not just like picking identities willy-nilly, but we're thinking about this, about what we can use. All right. Back to the top with Colin and Jake. Let's look at number 9 here.
algebra?
Okay, what algebra do you think? Well, I mean, I want to hear why you think that, and then we can talk through whether it's a good idea or bad idea. Because right now, me just telling you yes or no is not helpful. I want to hear what you're thinking so we can, because it's a fraction. Okay, what algebra are we going to do with the fraction? Okay, you want to try to divide that thing. Okay, or you want to try to multiply the top and bottom by something? Okay, so that is something you could do. Like, that's a legal move. I don't know that it's going to be helpful here, but that is something you could plausibly do and might be helpful in another situation, but not this one, I don't think.
Can be P1.
Very good. Yeah, I love that idea. I think that you'd start with an identity, and the first Pythagorean is the one you'd want.
Is it because P1 is sine squared? Yeah.
But what does sine squared plus cosine squared equal on your identity sheet? 1. Do we have a 1?
Yeah.
So what we can do is we can replace the 1 with sine squared plus cosine squared. Does that feel okay?
So you plug the 1 back in.
So I used P1
Yep.
to replace the 1 with the sine squared plus cosine squared.
It's just going to equal. Yeah.
Okay, that feels pretty good. Who's next? Is it Layla and Avery? What do we see to do? This should be pretty easy because there's something really obvious to do here. Now, I can't do that because there's addition, subtraction, the fraction. But look at the numerator. Yeah, cosine, I have a positive cosine squared minus cosine squared. What is that? Yeah, they just cancel each other out, right? They go to 0. Okay. Mariana and Nora. What can we do now? We have sine squared x over sine x. Mariana? Yeah, just reduce it. We're doing more algebra. How does that reduce? So what are we left with?
Or sine.
And are we done? Yeah. Yeah, that's a great question. So Nico's asked, like, what if I just stop writing the x's? I'm gonna mark wrong on a test or whatever. If you drop your variables, it'd be like you having like square root 2, and then all of a sudden down the road you just have square root. Yeah. Like you can't just have just like it has to be of something. You know what I'm saying?
Yeah.
Okay. 10. Let's see. Paulie and Nico, I think you guys are up, right? Yeah, go ahead.
No, because there's no square in it. Oh, I do see a square.
Like,
I was looking at number 8. Oh, I was looking at the wrong problem. Wait.
we're doing 10 right now.
Yeah, I was looking at 8 still. Wait, let me. Yeah, those are 10. I feel like 8 is still.
Let me give you a helpful hint here. I would not, you could use that there because you have the cosecant squared. I would not. Okay, hold on everybody. So these guys suggested trying P2 and I told them I would not do that. Let me explain why, right? Because it's just as important to hear that part. When I have something in my denominator, I'm concerned about potentially having to make a common denominator later on. The last thing I want is addition and subtraction in my denominator if I don't have to have it. I'd much rather have cosecant squared only down there rather than 1 plus cotangent squared, where now I have like addition and subtraction going on down there. I'd much rather just leave it the way it is. Let me give you a hint here, fellas. I would do an algebra thing to start this.
Oh, so. Yeah. Yeah, can you?
Do they have a common denominator? So you could make a common denominator here. That would be okay to do. But I would say there's something even... So that's a good idea. I want to be clear. And that'll get you to where you need to go. But there's a faster route that we could take here that's algebra. And now you've identified what you needed to see in order to access this. So you notice that the numerator of each of these fractions is the same, correct?
Yeah.
That means that we have a greatest common factor here of tan x. What if we factor that out to start? That's going to be the best first step. Now, I want to be clear. If you decide to make a common denominator here, that will work. That is an okay idea. It's a good idea. It's going to be a little bit longer than what we did here, but it will work. It'll be fine. You have to be a little bit careful. The advantage here is it's going to be a little bit quicker to where we need to go. All right. Yes. Avery and Sydney, you guys are next, right? What do you see that we can do here? Algebra identity. What are we looking at? Okay, great. I love that idea. To be clear, if you would have said make a common denominator, I would make the same comment that I had made to Paulie. Good idea. You can do that at this step, but there's going to be a faster way to get to the end than making a common denominator here. I like the identity route. What identity do you see?
Probably reciprocal.
Great, I agree.
So maybe R3.
R3.
No.
Okay. I love that you corrected yourself. And in fact, I would use 2 of the reciprocals here.
R1 and R2.
Great. Now notice that on your identity sheet, R1 says sine theta equals 1 over cosecant theta. We have 1 over cosecant squared theta. Does that matter?
Yeah.
Yes. So what do we need? What is 1 over cosecant squared theta going to become then?
CSC.
It's going to be sine squared, right?
Oh, because you're taking the inverse of cosecant.
Because I have cosecant squared down here, it's going to be sine squared, right? Is that okay? Well, I mean, if I think about it, I'm thinking about it this way. Cosecant squared, 1 over cosecant squared is this, right? So I do R1, that's sine x times sine x. That's sine squared x, right? So I'm just kind of like cutting out the middleman. In general, for all of these reciprocal identities, if I have like 1 over like sine to the nth power of x, that's just going to be like cosecant to the nth power of x. Right?
Oh.
Whatever the exponent is just stays, is basically what we're saying. For all of those in that first basic block, the reciprocals and the quotients for that matter, you can do the same thing.
Okay.
Does that feel okay? All right. So when we apply R2, secant squared x becomes something. Secant squared,
No. Oh,
cosine squared. Okay, great job. Reese and Delaney. The green was from the previous problem, right? That's not relevant to this. Let me erase it. What do you think?
P1.
Awesome. What did you see to tell you that P1 was what you wanted to use?
Sine cosine squared.
Yeah, we saw sine squared plus cosine squared. What is sine squared plus cosine squared equal to? 1. Ooh! And what's 1 times tangent? Tangent. And we're done. That wasn't too bad. Now, if you made a common denominator, we would have had to like some extra layers to kind of go through to get there. I tend to want to pass on that. But
What did I miss?
some good stuff.
Theory problem.
By factoring that tangent out in the beginning, really sped this thing up. Ready to look at, what are we on, 11, I think?
What does the B?
What's up?
What does it should be?
The B?
Yeah, what's the B?
Where?
On 11.
Oh, on 11. That's the Greek letter beta. So it's just the variable.
Oh, so it's like.
It's like an X.
It's like beta or X.
All right, yeah. Yep.
Can I use R2?
Okay, so it's now Jake and Colin's term. To answer to you, Delaney, that's not what I would do first.
What's the B?
It's just a variable. It's like an X or theta. It's the Greek letter beta, but it's just the name for the variable in that problem. Jake and Colin, what do you guys see? On the tangent squared? Is that what you're saying to do? So let me be clear. You could do that. I want to be clear. That would be using the identity appropriately. I tend to not want to make a fraction inside of another fraction, that's usually not going to be something that I would want to do. But you could do that. It would not be wrong to do that. But I don't think it's helping us get to where we want. What?
But there's a better one in the other.
Yeah, I think there's a better choice to make here. Hold on a second. I want to.
Sorry, I wasn't.
That's okay. I want to give like these guys a chance to think about it, and everyone else a chance to think about it.
No, I just had a question on my end.
Oh, sure.
Will we like get this on a test?
Yes, not something you'd have to memorize. If you're planning on trying to take like a calculus course in the future, you probably want to memorize these because there'll be an expectation that you know this. But for this class, I would not require you to memorize it.
It's not eligible.
I would not do an algebra thing here. Good thought to circle back and like double check that maybe there's an algebra thing to do, but I don't see anything that I would plausibly want to do.
I think our only, we don't know what else are in Q1, Q2.
Okay.
That's still like, it's still a fraction.
So can I point something out to you? What else do you have in the numerator other than tangent squared?
Science,
And
science,
what operation is going on between them? And you can add those things in any order you want, right? So you could look at that part right next to each other, right? Yes! P1. That's the quick way, or the quick observation to make. That's going to speed this thing up enormously. Okay. Avery and Layla. What do you see next? Again, you guys should all be looking for stuff to do next. There's a good one, good thing to do.
Oh, wait.
Yes. So an identity is what you'd want to use there, and P3 is the identity. What is 1 plus tangent squared?
Tangent squared.
Secant squared. And Mariana, you keep getting the same step here. What should we do next?
Reduce.
Reduce. And we're left with just you keep getting the same step where there's nothing else to do other than just do some reducing. Polly, what's up? Absolutely. You're going to be really good at seeing it, though. You've had all the practice. What's up? Easy step. Maybe we'll start with you guys next time and go in the reverse order.
That's fine.
Look, it's just practice, guys. Like, there's no penalty for wrong answers. Lots of people put wrong answers out and said, like, you know, stuff you can't do or stuff just is good. Like, that's something you could do, but I wouldn't, right? Like, it's fine. All we're doing is trying to build some intuition, like, help you guys learn, like, what are good ideas and what are bad ideas. Like, what can I do? What can't I do? Nora. Of course. All right. 12. Where are we? Nico and Paul? I guess just Nico here today. What do you think on 12?
Odd even identities way. Is it O?
Okay, you can use that one. Might as well use the other one though also, right?
Yeah, the OE2.
Yep. So that's the obvious two things to do. Now I want to be clear for a moment. You don't actually have to do that. Since the variable part is the same, it's negative x in both of them. You could skip this step but that's okay to do it here.
Learning.
I would say, and again, I would say that 90% of the time, even students with experience would do that as their first step, you know. But since they're the same, they're both negative x's, you technically don't have to. Yeah, I think it's is it your turn? No, it's Sydney and Ava's. You did good. What are we thinking here?
Are we like adding them? Are they?
Well, there's a multiplication symbol between them, right? It's just we don't write it. That's a great question, though, right? If you're not sure what the operation is or like what the convention is, like ask. And you look at this, and there's obviously no algebra that can happen here, right?
Yeah.
Has to be an identity. Which identity? There's two choices. What?
What about R5?
R5. That'll work. So we can rewrite secant as 1 over cosine. And then Reese and Delaney.
Oh, yeah. So cross multiply.
Well, you don't mean cross multiply, you mean
Oh, cancel.
reduce. And what do we get?
Theta equals 1.
Just 1.
Probably.
Yeah. Reducing queen, did you see it? Is this feeling easier as we're getting through?
Yes. Totally.
This is necessary. Like we have to just like do this together. We have to pause, we have to think, we have to spit out ideas. I have to tell you whether it's a good idea or bad idea and why. Or even like an okay idea, but not what I would do. Like there's a better idea still floating out there. Because this is how you're going to develop your intuition. You're going to develop like, okay, these are the kind of tricks I can use to do with these problems. And you just have to see it. Like you have to see it, you have to try it, you have to think about it, because it's not just one procedure. You can take 3 steps to do one of these things. You could take 13 steps to do one of these things, and it still might both be correct. All right, let's see. Nora and Mariana. We'll start with you guys here for 13. So the only operations that are distributive is multiplication and division. That's not cosine times something, because cosine's not a number, it's an operation. So you definitely can't distribute a trig function. Great, yes. You would use your co-function identity, C1, and that allow us to replace cosine pi over 2 minus alpha with just sine alpha. Great. Avery and Lila. Algebra, identity, something else. Okay, what are you thinking? The like terms, right? Yeah, sine plus sine is x plus x squared? So sine plus sine is, there you go, 2 sine. That seems like a good idea. Nothing wrong with that. Colin and Jake. Identity, algebra. Seems unlikely there's more algebra to do, considering you just did it.
That's two sine.
Correct. 2 sine alpha minus tan alpha times cosine alpha.
What is the thing that's wrong?
That's an alpha. It's just another Greek letter. It's like an X or or a theta or.
Oh, when did that get you?
That was A.
Me too.
Well, when you write an A, I only write my A's with a tail at the bottom. This has an extra tail at the top. That's the Greek letter alpha.
Can you put X?
Where did alpha
Where do you have to put A?
Did you just use alpha just as like a variable?
Yeah, just a variable name. Like I call it, you call it taco and draw a little picture of a taco. It's just the name of the variable.
The A is not supposed to be
You can write as letter A. That's fine. That's what the Greek letter alpha looks like. But whatever. Colin, what do you got?
The C2 word.
I would not do another co-function identity. You could use C2, but right now all my variables inside are the same. And by using C2, you'd make one of them different. And I probably don't want to do that because I won't be able to reduce anything unless they're the same. So you could do that. You have the things that you need to use it, but I would not.
P1. Yeah, that's what
We don't have anything squared.
You have the quotient.
Yeah, which one?
I1.
Yes, which version of it? Do you want sine over cosine or secant over cosecant? Excellent, I agree.
Yeah.
This was Q1. Okay. Nico and Paulie, what do you guys see to do next?
Cancel.
Yeah, absolutely.
Oh, that's the last thing.
So I have 2 sine alpha minus sine alpha.
So it's sine.
So just sine alpha, right? Beautiful. And then we're all done. I had 2 sine alpha minus 1 sine alpha. How we feeling? Tired, but like getting better at this?
Yeah, it's actually kind of makes sense. Like I like learning like this better than the notes.
Yeah, I like this.
Well, here's the reason we can do this here because there's not a set procedure. This is just about like, we need to build some intuition. We need to learn the kind of tricks that we can do and not do. And this makes a ton of sense to do it this way because there's like nothing new in this chapter after we had like discovered the identities. There's no new ideas. It's just like learning how to use these things.
We get the homework done and we learn.
Yeah.
That's a good trade-off.
All right, last one. Who are we at now? Oh, Ava and Sydney, right? All right, ladies. 14 is the last one. What are you thinking? You can't use a reciprocal identity here because you don't have 1 over sine. You have 1 minus sine and 1 over 1 plus sine. So the reciprocals are all out.
Were we doing even odd identity?
I would not because your variable is already the same. And I would not use a co-function identity because your variable is already the same.
Okay, questions do.
Can I give you a hint?
Yeah.
It's not an identity.
Oh, so it's just algebra.
You need to do an algebra thing here.
Okay.
There is no identity that you could use at this step.
So that's literally it.
What algebra thing do we need to do?
Can we do this for the other part? Can we do this for
Algebra.
We probably just like add, right?
Don't you
Well, we need to get.
you need to cancel out the signs.
You can't cancel the signs.
Cross multiply.
We could like put the sign on top, right?
You can't put the sign on top. What are you trying to add together right now?
Probably the one.
So 2
No.
over.
Delaney has the correct answer.
common denominator?
Yeah. You need to make a common denominator
Oh,
because these are 2 fractions that are being added. All right, Ava and Sydney, what would the common denominator be? between 1 over 1 minus sine y and 1 over 1 plus sine y?
What about 1?
Nope.
Something
It is something.
that.
Well, I'm just like
What do we like?
getting it ready for when we figure this out.
Okay, so we can multiply that one by like -1, right? Or -1 over 1, and then we will get a same denominator.
You would get -1 plus sine y, which is not the same as 1 plus sine y.
Okay. Oh wait, do we cancel the ones from the top and the bottom?
You can't cancel with addition and subtraction.
Oh wait, multiply by negative sine y to get 1 in the denominator, so you can get rid of the fraction.
You thought you had that too.
I thought I had it.
So if I have, so here's okay. Let's just
You got it figured out.
let me help explain, right? So what factor is in common between 1 minus sine y and 1 plus sine y?
I mean, y. We have
sine y to the second.
Okay. Just before we start yelling things out all at once, what factor other than 1 is in common between the two of them? Y is not a factor.
So it's sine.
It's sine is not a factor because it's being added. Sine y is one thing, right? But it's not 1 times sine y. Sine y doesn't divide this evenly because it's 1 minus.
So if it's not 1,
It's
it's sine
1.
or y, is it
1 plus
Minus?
sine. Oh, 1. So for the first
So, okay, it's not 1, it's not sine y.
one. But just addition. Yeah.
It's not addition and subtraction, that's not a factor.
So will we multiply by the reciprocal?
You've eliminated a lot of stuff, right?
You have to multiply with -1 sine.
What?
Oh my gosh.
No, it's gonna be.
Okay,
We stop shouting out answers.
so
How about you help me?
so here's
I already know.
here's the answer on the factors in common. Nothing. There's no factor in common other than 1. So that would be the same as like adding like 1/2 and 1/3. There's no factor in common between 2 and 3, right? How do you make a common denominator between 2 and 3?
You multiply. Oh, so you multiply the 1 over 1 minus sine y by 1. Yeah.
Yes. That's what we need to do.
Okay. So then.
Okay? So again, I wanted to let you struggle through that and like get all the bad ideas out and let me tell you why they're bad ideas and why they wouldn't work before we went and just told you what to do. Because you're going to remember it better. Because you've eliminated like, okay, I had this idea. Nope, that's a bad idea. Okay. What about this idea? Nope, can't do that. Mr. Cook told me why. So we just purge all those ideas that you might have had on your own. So when it comes test time, maybe you don't think of those anymore. Because they're just out of there. Okay. So when I multiply 1 minus sine y to 1 plus sine y, what do we have to do to multiply those two things together? Foil. And in fact, if I look at this, this looks like a familiar multiplication pattern, right?
1 minus sine y squared.
I have, yes, very good. That's like an a plus b times an a minus b. So Sydney says that should just be 1 minus sine squared y.
What is the y be squared to?
No. Because sine y is just one thing. So here, let's say this, because that's at Sydney. the question you asked was a good one because it reveals like a little misconception that I'm sure you're not the only one that has. So when we write sine squared y, what we really mean is sine of y, all of it squared. We write it as sine squared y just for convenience sake, so we don't have to have like all those parentheses, but that's not the same thing as sine y squared. So just like good opportunity to kind of remind ourselves of that. All right. Delaney and Reese. What do you think? What can we do here? So yeah, in the numerator you can certainly combine some like terms, right? That's fine. Nope. But you're close. What can we do in the denominator? Switch it to what?
Can you change it to cosine? Can you not change it to cosine?
There you go. Or cosine squared y, you mean? So we use P1 to replace the 1 with sine squared minus cosine squared. That's right. Close.
Y, no, SEC, y squared, right?
So think about it that way. Because what's 1 over cosine squared y? That's R5 to secant squared y. I know it was, but I was giving you a hard time about not saying it. It's okay. And we're done.
That might be like top 5
Okay. Guess what though, guys? We did the whole homework set together. Okay?
I feel like we should have like one a week.
We'll do this again. So last time I had assigned 1 through 6. And this time we assigned 7 through 14, but you guys are done with 7 through 14. If you finished 1 through 6, there's nothing new to do. Sunday's problem set is even just the chapter 4 stuff anyways, right? The last was like 17 to 23 and worksheet 3 in the review or something, I think is what it is.
That's due Sunday.
That's what Sundays do, but that's all chapter 4 stuff that we probably finish before the test anyways. The next Sunday is 1 through 13 so far, but we've finished 7 through 14 already today. If you didn't do 1 through 6 yet, you still need to kind of do that, but that's not bad. Next time we're going to talk about another type of problem that we'll be using algebra and the identities to do. It's called verifying. We'll do something similar, and we'll do like a bunch of them as a group. And anything we don't finish, you'll be left to do as practice. And there's a lot of them, so we won't finish them all, but that's okay. And then we'll finish up with solving again. And that'll be the last topic we'll see before the final. So we have like 2 more days of stuffs. Maybe take more than 2, it's like 2 more lessons or whatever. May take more than 2 days. But that's the last of it. How you guys feeling? It's all right? today was pretty productive. I appreciate how hard you guys tried, right? Hopefully you feel better about what we are doing than when you started. You know, that last one was a toughie, but hopefully once you got the common denominator piece, you could kind of see your way to the finish, right?